Hi there, I'm Phil Van Allen, and this is a tutorial on how to use the Kinect with the NETLab Toolkit. So let me just show you how this works. You can see that the Kinect, which through NeMate, which is on the right, has found my skeleton, and then in Flash on the left, those circles are each joint of my body. Now, notice also there's that red square, and that red square is being controlled by the analog in and is also tracking one joint, which is my left hand. Let me show you one more thing. So here you can see that I'm also running this application on an iPad, and we're connected to an Arduino. And so as I move my hands around, if I move my left hand over, it's connected to the digital out in the toolkit, which then turns on that LED you see in the lower right of your screen next to the Arduino. Got it? So what this shows you is that we can connect very easily with no code the Kinect to Flash to the Arduino, and we can also run an app that talks to the Kinect and the Arduino on iOS devices like the iPad and iPhone. All right, let's get started and see how this works. Okay, first I want to show you that all this information is here on the NETLab Toolkit website under Learning, Tutorials, Kinect. So all the information you need is here, and you can refer to this at any time. So we're using two different applications to work with the Kinect. The first one of these is NeMate. This is a new product. It's in beta right now. Right now it's free as well while they're in beta. I assume they're going to charge, but who knows. The other one is Synapse. And Synapse is an open source free application and should always be free. So you've got two good options. Each has its advantages. Today we're going to be using the NeMate. Okay, so as I say, all the information's on this web page, and we'll refer back to that a little bit here in a minute. Now, the first thing you can do is download the Kinect Skeleton Demo NeMate from that page you just saw, and that's what you see right here. So let me just run this, and so you can see it. Okay, and let me bring up NeMate here so you can see both things. All right, so you can see that as soon as the Kinect detects my skeleton, Flash starts presenting them. And if I use my left hand and move it over, you can see that the red box moves. So there's two things going on here. All the balls you see that are the full skeleton, those are happening through the through code. But you don't have to write code to work with Kinect. You can just use the regular widgets, and that's what's happening with my left hand. So my left hand, again, is just using the analog in widget with clip control. And so note that the OSC input is set to number 15. Okay, so 15 is happens to be in the set of skeleton joints that come in from NeMate. This is the X of my left hand is set at position 15, and this is all documented here on the page. So let me just show you that. So you can see here for both the NeMate and for the Synapse that there are 45 different coordinates coming in groups of 3. So for the NeMate, 0, the X position is for the head. But we're using the left hand, and so you can see that here. Left hand is number 15. Now, if I wanted to get the Y, I would use input number 15, or 16, rather. Okay. So there are a couple adjustments you can make to the analog in to make this work a little bit better. So you can see that while the balls, which are run by code, are getting a full range, notice that my left hand, nothing happens until I get to the halfway across the screen, and then the red box moves. Well, the reason for that is that the numbers coming in from NeMate are both negative and positive. So if I change the floor of the analog input widget to negative 1023, now, oh, it's confused. Sometimes it gets confused and you just have to, there we go. So now you see that I'm getting both all the way across, but the square is still a little not quite centered where we'd want it, and that's because the max of the analog in is set to 1023. So if we dial that in to 550, which is the width of this Flash document, now we've got it almost perfect. So now I can move my hand over and across, and we get more or less the full range. You can adjust all these numbers to get it exactly dialed in to how you want. Okay, so that's the demo, and that includes the code which you can use it as an example to develop your own code for dealing with all 15 joints that are available from the Kinect. But let's take a look at a much more simple example. Say you just wanted to use the Kinect to track someone coming into a room and follow them around. You don't need all their joints, you just need to know where they are basically in the room. So let's do a simpler demo that allows us to do that. Okay, so we'll just go into Flash here, and starting with a fresh ActionScript 3 document, I'm going to first drop in analog in. And in this example, again, we'll be talking to the NeMate, and or NiMate, I don't know how they pronounce it. Okay, so first thing we want to do is switch the controller to OSC, because NiMate speaks to everything else via OSC. All right, and then in order to listen to OSC, we need to tell the analog in widget what string of OSC we're listening for. And so this first one I'm going to try, I'm going to use head. And this corresponds to the just getting the head value from the NeMate. Okay. So the next thing we want to do is we have a multiplier here. So the numbers coming in from NeMate are decimal, and they're between -1 and +1. So we want to multiply those numbers by a number, and let's multiply them by 3,000, which will give us just about the right range. Okay, and so for controller number, we're going to go with 0 because we're just getting the head. So the x coordinate of the head will be 0, the y will be 1, and the z axis, that is forwards and back to the Kinect, will be number 2. And the last parameter of the analog in that we want to set is the controller port here. So NeMate communicates on port 7000. If you were using Synapse, you'd be communicating on port 2202. Okay, so with that, let's call this up, test the movie, and also let me bring forward. Here we are. So now you can see if I move my head, we've got an input. So we've connected to the Kinect with no code, just the use of the simple analog in widget. Now you may notice that we only see input when I get my head halfway across the screen. And the reason for that is that NeMate actually outputs numbers from, as I mentioned, -1 to +1. And so if we want to modify the floor here, so we're going in a range of -1023. Now I've got the full range from left to right. Okay, so let's do a little more with this. So let's control something here. So let's put a clip control out on the stage. So the clip control will listen to the analog in and then move a graphic on the screen. I have a graphic ready to go here in my library. Okay, now when we're working with the widgets, as you've seen before, if you've used them, you have to name everything. So we're going to name the analog in input 0, and we'll name this ball here clip 1. And then if we look at the parameters for the clip control widget, you see it's going to listen to input 0, which is the analog in, and then it's going to control a clip named clip 1. All right, so let's run that. Okay, so you can see now as I move my head, I'm moving a graphic across the screen. Again, all with no programming or anything. All right, very good. So I have another demo already prepared here to show you how we can do the same thing and actually control the physical world with the Arduino. So I'll run this one. Okay, And notice that when I get halfway across the screen or so, that little light goes on in the digital out. So let's see how this is actually affecting the world. So now you can see as I move my head around, the light connected to the LED goes on and off. Now the video capture software I'm using introduces a little bit of a delay, but be assured that it actually works instantly in the real world. Okay, so you can see that we're connecting the Kinect to Flash, and the Flash is then talking to the Arduino through the NETLab Toolkit. Okay, now I want to show you some code. We've seen so far how you can use the widgets to access the Kinect with no code at all, but if you want to use the Kinect and get, say, all 15 joints, that's a little beyond using just the widgets, because you have 15 joints times 3 coordinates for each joint, x, y, and z, so that's a total of 45 numbers coming in, and we don't really want to have 45 analog in widgets on the stage. And so I've got some code here that I've had commented out. Let me just make that active. And let's just walk you through a little bit. So the Kinect sends information to the toolkit by OSC. And OSC is a protocol. Basically, it uses this prefix here, like you can see here, slash skeleton, or we were just using slash HEAD, head. And then a series of numbers after that identifier. And so each one of these numbers is a parameter of the OSC message. And so by selecting, as we discussed before, the controller input number, we were picking one of these numbers out of the set. Well, so, but what if we want to work with them all at the same time? That's where code comes in, is very useful. And so in a recent version of the toolkit, we introduced this idea of multi-input to the analog input widget. And so you may remember that the analog input widget is named, has an instance name of input 0. And so we use this syntax here of multi-input equals process input, and process input is a function. So here we are, and we have a function. So we've set this up, and so now this function will capture everything that comes in from OSC in the analog input. And the format here, this may be unusual if you haven't seen this in ActionScript before, but this is a way to accept a variable number of arguments in a function. Okay, so all we're doing in this for loop then is cycling through as many number of arguments as have been passed. So that's identified here by args.length. And because it's x, y, and z, we're selecting, we're advancing the counter in the for loop by 3. So let's go ahead and run this, and we can see the values coming in from the Kinect. So I'm moving my head back and forth, and you can see the 3 values down here, and going from left to right, they are the x, the y, and the z. So you can notice that the x right now is negative. That's because I'm to the left of center. And as I move to the right, it goes to positive. And if I move down, my head down, let me pull the NeMate up so you can see. So as I go up, that middle number goes positive and then negative. And z, it doesn't go positive or negative, it just goes forward and back. So the closer I am, the smaller the number is, and the further away, the larger the number is. Okay, got it? So if we close this and just go back to the code once more. So you can see those are the numbers that are coming out. All right. Just to briefly show you the code for the demo that you can download that has everything and shows all the balls. Let me just show you that. So this is a bit more complicated in code, but really not that much more complicated. So here we're just building an array with some joints, and here we're essentially building all of the circles. So that's all that does. It builds 15 circles. Here again, we have the multi-input calling this function process input, which is here, getting our variable number of arguments here. And then the for loop, and the for loop goes through all 15 joints. And then we simply get the x, y, and z for each joint. And then we're doing a little bit of math just to sort of massage the numbers a little bit. But essentially, here's the y of this joint, the x of that joint, the y of that joint, and the z we're not really using exactly. We're using scale. But we're just varying the size here from the z and setting the scale. So we're not using the flash's z coordinate, but it still works. So again, we can run this. And so as I set up, so there's all the balls. So again, those are all being controlled by that code that you just saw. Okay, before we wrap this up, I just want to show you a few things in NeMate. So let's take a look at this. And so right now we're in the Depth View tab. There are several other tabs, but the one I want to talk to you about is OSC. So here we have the general one. The ones I want to talk about are skeleton. So by default, I think this is set to basic. But to get all 15 joints all in one message, you want to set the format to Omni. And you can see these are some of the other messages that you can also tap into. So over here in exact, you can see you can get body, head, hand left, hand right. And these four, by the way, don't require that the skeleton be active. So you can see if I go to depth view, like right now there's no skeleton, but you can see this H and this B, that's head and body. So the Kinect can much more easily find those minimum ones than the full skeleton. Only when I step back, now you see the outlines there. Now it's got the skeleton. But if I come up closer, or if I've just walked into the room, it may not identify the full skeleton. And so it's often, if all you want to do is track someone in a room without all the joints, it's better to use the body and head because the Kinect can find them so quickly. That's, again, these exact. And if you want a little more control, again, it'll find the left hand or right hand pretty quickly. All right. So there you go. That's NeMate, and you can also use Synapse. Synapse requires the person to get into the PSI position, as they call it. That's this one. Now it's all confused. So with the Synapse, you have to get this position first to calibrate the Kinect, whereas in NeMate, it doesn't require that initial calibration. Okay, again, be sure to check the website and take a look, and I hope you find this all interesting. Thanks a lot.